Hello everyone, I am Sherlon and I am a master student at the Institute of Mathematical and Computer Science at the University of São Paulo. Today I'm going to present you our work titled Evaluating Visual Analytics for Text Information Retrieval. Initially, the introduction and motivation of this work will be presented. Visual analytics is a research field that provides interesting data exploration ways to obtain helpful information. Its ability to identify patterns and present them intuitively is essential for helping the users to get insights and discover relevant information. However, there are scenarios, for example, in rich information retrieval, that the user needs are not clear initially. Thus, interactive approaches are employed for helping the user seek relevant information while she refines her needs. Usually, a system may facilitate user exploration, but there are some challenges in evaluating them. Due to a complex nature and diversity of tasks, conducting user sessions in real settings demands high cognitive effort and a steep learning curve. Another concern is the restricted availability of participants, once it is difficult to find people who fit the investigated system's requirements. Retrieval is an example of a system for this purpose. The user can explore documents and their relationships to identify relevant information. In the Retrieval interface presented in this figure, it is possible to observe the corpus documents denoted by the circles in the scatter plot view in the center of the interface, where the colors represent their relevance. Also, several supporting functionalities are displayed around the main visualization. Retrieval was implemented using an active learning protocol for document retrieval. The documents are classified as relevant or not relevant with user guidance. The user inserts a document already known as relevant and a document collection to the system. The system learns how to indicate potentially relevant information based on the query document and user feedback inside an interactive process. The problem is that the visual analytics and techniques and exploration strategies were not evaluated in Retrieval, considering the user needs and goals. Also, it was necessary to validate the system with potential users in real settings. In this work, we investigated and applied validation strategies from visual analytics and human-computer interaction to validate and evaluate Retrieval to assist a user in identifying relevant information according to her needs, with high recall, which means that none or very few documents will be missed. User studies. To do that, we proposed to conduct 3 user studies called Preliminary Study for formulating relevant materials for the subsequent sessions, such as the total time, the presentation, and questionnaire details. Investigation Study, called S1, to validate the original version of the Retrieval system and identify limitations and propose solutions. Furthermore, Validation Study, called S2, validates the new version of the system implemented in this work. To do so, a project was appreciated by the Human Research Ethics Committee. The user studies consisted of a user session where users provided one or very few relevant documents to use as queries. A search string was used to get a document collection of her interest in a platform such as Web of Science, Scopus, and so on. Although Retrieval supports different kinds of documents, our studies used scientific articles composed of title, authors, publication year, and abstract, downloaded in CSV, BibTeX, or textual format. Each session was planned for at most 3 hours. However, the users were motivated to explore how much time they wanted. The preliminary study was composed of 5 users. In comparison, the investigation and validation studies were composed of 9 and 11 users, respectively. After the corpus exploration using Retrieval, the user was invited to answer a questionnaire composed of 2 main parts. The first one aims to measure the usefulness of each system's functionality, and the other one to evaluate usability aspects of the software usability scale questionnaire. After the investigation study, a new version of the system was implemented, considering the user's opinions and suggestions, to tackle some of the limitations identified. This new version of the Retrieval system was validated in a new round of sessions, previously mentioned as Validation Study, or S2. Results. This heatmap presents the ratings by participants in the study S1, measuring the perceived usefulness of each functionality of Retrieval. We note that the experienced users were more critical in general. Moreover, the functionalities evaluated by the questions 4, 7, and 10 obtained the lowest scores. For example, the KNN filter in question 4, which allows filtering the most similar document, was static, filtering only about the initial query. Another limitation was the bad quality of the terms view in question 7, which provides not interesting synonyms. Also, information shown in list views in question 8, 9, and 10 were redundant according to the user's opinion. Participants also identified minor issues, for example, reading the document view details displayed as non-formatted text, interacting with a similarity map when the higher number of documents yields overlapping the circles, and among others. After conducting study S1, study S2 was conducted with 11 users. 8 of 1 participated in S1, plus 3 new users. The questions in this study were divided into 3 parts. This figure corresponds to the same 10 questions asked in S1, related to the functionalities of the original retrieval. Consequently, the same patterns of evaluations and limitations were observed. The proposed solutions were well accepted in general. The users mentioned that the new filters provided a flexible way for data exploration. For example, the link distance improved the segregation of visual clusters, the neighborhood parameter allowed to filter similar documents by an arbitrary query, and the edges avoided the information lost by the multidimensional projection, improving the relationships in the projected space. Furthermore, the session data and system status made users more confident about exploration. Buttons facilitated the interaction with the system, and the guided tutorial enhanced the user autonomy. Regardless the cosine distance being useful for most users, its underlying concept was not intuitive according to the users. The word cloud view was helpful in summarizing the document content and allowed to discover its main topics quickly. It was also helpful to identify the main topics of visual clusters in force layout, facilitating the labeling of several documents simultaneously. However, the colors were not intuitive, once they had no particular meaning. About both visualization of the system, the users think the force layout is more intuitive, as the user can now switch between the projection and the force views. In question 20b, we asked her preference for one of them. 7 out of the 11 participants declared to prefer the force layout map. In contrast, 4 declared they alternated between both visualizations in different situations and saw them as complementary. Observing the answers in question 1, we note participants were in general extremely positive on the willingness to use the system frequently in both studies. Overall, usability scores improved, and participants found the new retrieval easier to use than they felt more confident about using it without support from an expert. The higher usability scores in S2 may reflect an improved perception resulting from both the modifications introduced and from the increased familiarity with the system, as most participants were running their second session. However, the more experienced users are aware of the challenges introduced by the inherent complexity of the vision analytics system that implements a sophisticated conceptual model. Conclusions. We investigated the suitability of techniques and strategies employed in Trivir, an information retrieval system in the state of the art, to facilitate the data exploration to obtain relevant information from document collections. We conducted user studies with potential users of this kind of system in tasks related to the user interests. Some of our main observations are that user assessment of some functionalities varied considerably and was apparently affected by her background. For example, users familiar with vision analytics or human-computer interaction were more critical in their ratings. This may suggest that evaluation settings should consider different categories of users. Regarding the specific visualizations in Trivir, interaction with the document similarity map provided in the scatterplot view yielded the most critical observations. Most participants preferred to interact with a force layout similarity map proposed in this work, considering the new visualization more intuitive for understanding relationships in data. As we conducted 2 rounds of sessions with mostly the same group of participants, we realized the fundamental role of a careful introduction to the interface functions, conveying the system underlying models and their limitations. Indeed, some users less familiar with the underlying abstractions may face difficulties in using the system autonomously in an optimal way, even though they might be unaware of it. Finally, we would like to thank the support of CAPES and CNPq. Thanks for your time, and feel free to ask me questions in Portuguese or English. Thank you.